Hello, students. We are now going to talk about the diagonals of a rhombus being perpendicular and that they bisect each other. All right, so let's jump in again. What we know is we have a rhombus. If it's a rhombus, it's a parallelogram with all four sides congruent. So we've got those from the first few pieces. Let's tackle this next one, and I will share my screen. All right, let's see here. Bump that. There we go. Okay, so once again, start with a rhombus. A, B, C, D. And we are going to draw the diagonals. So I'll start off with A, B, C, D is a rhombus. And draw BD and AC. All right. So here we go. As I draw these in, okay, those are the diagonals. Yeah, they don't look great because my line didn't go straight over. I should have used my straight edge, but all right, we'll leave it we'll leave it as it is for now because that is the no, I don't think I can. I'm gonna make a better line than that. Okay, just because I think there we go. I stick a dark line there, and we'll draw one right here as well. Okay. There we go. That's a little bit more clear. All right, so what we've got is we know it's a rhombus. A rhombus, all sides are congruent. So I'm going to go ahead and mark those off. So I'll just say all sides are congruent. That's a previous proof. We don't have to keep proving things over and over again for the same thing. That's nice. So I now have this. I also have BD and AC, and this is where now I can choose kind of how I want to go about doing this, but BD and AC, and so I'm going to say BD is congruent to BD by reflexive. And you know what? AC is congruent to AC by reflexive. So we'll make both of those by reflexive. All right, so now let's take a look. What we're going to try to show is we're going to try to show that the angle that these intersect at is a 90-degree angle, which would make them perpendicular. And I'm going to try to show that BD is bisected. So I'm going to call this point in the middle M, but I'm hoping that the BM is the same as MD and AM is the same as MC. That's what I'm hoping. Okay, that's my goal. All right, let's take a look. So what do I have? I have a couple triangles that are congruent. So let's utilize those. All right. So I have a triangle ABC, triangle ABC is congruent to triangle ADC. There we go. By side, side, side. Got it. That means angle. Let's see here. Angle A. Let's see here. BAM is congruent to angle DAM by CPCTC. Okay, so let's mark that. This angle here is congruent to that angle right there. Okay. And now what? What else do I get for free in this? I mean, that might be all that I need. We know that triangle ABC is isosceles, right? Let me put that up here. Both are isosceles. So when we know these two angles are congruent, then I guarantee the angle over here has to be the same because this isosceles triangle, the base angles are congruent. So I'm going to say these are congruent by CPCTC and angle ADC CB is congruent to angle ACD by isosceles. I'll put a little happy face there because that's kind of a nice one. All right, so now here's what we're going to do next. We're going to look for some congruent triangles, and let's see what we can get. Because I really want these. I want triangles like down the middle. Ooh, triangles down the middle. I like that. So triangle ABM is congruent to triangle CBM. Let's take a look at why. Okay. Let's see here. A to B to M is congruent to C to B to M by angle side side. Oh, see, that's a problem. So even though BM is congruent to itself, right? It's now angle side side. So we do have a little bit of a problem there. I need one other angle. Okay. So I could hold on this. Let's see here. Could I come up and do it? Oh, I could use the other triangle. So I wanted to use this, but this is angle side side. So that's going to be a sad face. So I'm going to come down to the other triangles. I'm going to triangle BAM with DAM. Those are congruent by what? Let's take a look. Side DA is the same as BA. The angle in the middle is good, and then AM is congruent to itself. By side angle side, AM congruent to itself. By reflexive. So now I do have two triangles that are congruent, which means their corresponding parts have to be congruent too. So angle BMA is congruent to angle DMA by CPCTC. These are supplementary. They found Kate Middleton. All right. She's okay. Oh, she's alive. Kate Middleton is alive. That's from my wife on the TikTok. Okay, these are supplementary and congruent. So that means they add up to 180 degrees and they're the same. And we can see from the picture there's two of them. So two things that add up to 180 degrees and they're identical would be 2 times x has to equal 180 degrees. So x has to be 90 degrees. So what does that tell you? The angles are 90 degrees, which means AC has to be perpendicular to BD because it forms a 90 degree. So that's pretty cool. Now, not just that, but if you take a look, I also get some other pieces from my triangle. See, BM has to be the same as MD because the two triangles are the same. So now I'm going to say BM has to be congruent to MD by CPCTC. And likewise, angle ABM has to be congruent to angle ADM by CPCTC. Okay. Phew. Okay, so I get this angle here, has to be the same as this angle up here. Right. Perfect. And what else? I think that might be it. All right. So I can go back and create, again, since we know this diagonal is an angle bisector, I also know this angle right over here would be the same. Okay. And I could repeat the process because what I've shown here is that I've shown you that this diagonal cuts BD in half. You can see that because BM is congruent to MD, cuts it right in half. And so I'll come down here and just say, similarly, AM is congruent to MC by CPCTC with, and this is where the one that came up earlier, ABM and CBM, ABM and CBM. I mean, that's fantastic. The only issue is I had at the time angle side side. Well, now I have side and I know the angle between them. So now I actually have side, side, side. Phew. With triangle ABM congruent to triangle CBM side angle side. So diagonals of a rhombus are perpendicular. Okay, and we showed that right here. And bisect each other. And that was by these two statements showing that the M value is right in the middle of BD and the M value is right in the middle of AC as well. So this again is a nice one that we can use with a rhombus. Anytime we make a rhombus, we can absolutely utilize these properties. So what we're going to do now is we're going to show you, now that we've seen how to prove them, which is great, we're going to go through our constructions. And constructions are going to go pretty quick. I'll probably do all constructions in one video. And that way you can just kind of see, well, what do I use this rhombus for? And that's what we'll do. All right. That's it for now. Off you go.